back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the February-March 2024 9709 Cambridge paper 1, which is a pure math paper. And this question here is about trig identities and equations. The first part of the question 4a is telling us to take this expression here and prove that it's equal to 2 times tan x. So we have here sine theta plus cosine theta squared minus 1 over cosine squared theta. Well, the first thing what we can do is we can take our sine theta plus cosine theta squared minus 1 over cosine squared theta, and we can square this bracket. We can open the bracket or expand the bracket. So we're going to square the first term. That's going to give us sine squared theta. Plus, we're going to multiply these two numbers together, or these two terms together, and then double that. That's going to be plus 2 times sine theta times cosine theta. And then we're going to square the last term, plus cosine squared theta. Then we got a minus 1 on the outside, and then we have this is all over cosine squared theta. Now, what we can do is we can bring the sine squared and cosine squared theta together, and we should know one of the fundamental identities is going to be, or is that the sine squared of an angle plus the cosine squared of the same angle equals 1. So these two together will give us 1. So you have, sorry, I forgot the denominator. That's all over cosine squared theta. So these two together, they add up to 1. Okay, so we can just replace them with 1. So we have 1 plus 2 sine theta cosine theta minus 1 over cosine squared theta. So the 1 and the minus 1 cancel out. And then we can think of this as 2 sine theta cosine theta over, if you want, this is like cosine theta squared, which is cosine theta times cosine theta. Why am I doing that? Because these can cancel out, and we're left with 2 times sine theta over cosine theta, which is exactly that, because our other identity that we know is that the tan of an angle is equal to the sine of the same angle over the cosine of the same angle. Those are our two identities that we should be familiar with. They are written in the Cambridge formula sheet, so if you forget them, you can see them there. So we end up with here 2 times, oops, there, still on the highlighter pen. So 2 times tan theta, which is what we have to show. Okay, so there's your answer to part A. All right, so you have to show the steps very clearly, and we've got that done, and that's very important. One of the things that you should take note of, it doesn't really affect this question, that this is because sine squared theta plus cosine squared theta equals 1, it doesn't mean that sine theta plus cosine theta equals 1. You can't say that. They have to be squared. Sine squared theta plus cosine squared theta equals 1. It's very important. In this case, it doesn't really affect us too much, but just for your information to take care of that. So part B says hence. So hence means using the result that we just got. And in fact, even if you don't know how to do part A, you can use the answer to part A to answer part B. So hence solve the equation, and then they give us this equation, sine theta plus cosine squared theta minus sine theta plus cosine theta in bracket squared minus 1 over cosine squared theta equals 5 tan cubed theta. So I know that this we can use part A and replace it with that, because this is equal to that. So I can say that 2 tan theta equals 5 tan cubed theta. And I have to solve this equation. So what I'm going to do is I'm going to bring everything on one side of the equation. So I can say this is 5 tan cubed theta minus 2 tan theta. And I can just take out tan theta as common. So I'll have tan theta, and then I'll have 5 times tan squared theta minus 2. If I want to, I can say let tan theta equals, u or something like that. I have 5u cubed minus 2u factorized, and then replace the tan u with tan theta. But hey, you don't really have to worry too much. It's pretty easy here. So that's equal to 0. So now we can say that either tan theta equals 0, or we can say 5 tan squared theta equals 2. So tan squared theta equals 2/5. Okay, so now we have to solve this equation between theta values between minus 90 and 90, between minus 90 degrees and 90 degrees. Okay, those are the limits that we have to solve this question in. Now, for tan theta equals 0, that's pretty simple. Theta is going to, what happened there? Sorry. Theta is going to equal 0. Okay, if you press inverse tan of theta, inverse tan of 0, you're going to get 0. The tan curve, as we know, between minus 90 and 90, you're going to have asymptotes. It's going to look something like this. Okay, does the question have to be in degrees or radians? Degrees. Okay, it's between minus 90 and 90, so that's included in our range. So that's one answer. And then here, we have to be very careful here, because tan theta, we don't say it's equal to the square root of 2/5. We say it's equal to positive or negative square root of 2/5. So we're going to have two sets of answers. We're going to have theta equals the inverse tan of the square root of positive 2/5, and theta equals the inverse tan of the square root of, or negative square root of 2/5. Positive square root of 2/5 and negative square root of 2/5. So that should give us two answers, which should be in the range. Let's have a look. So inverse tan of the square root of, and we have 2/5. Okay, that gives us, what did I do wrong? There's that sign sticking out, 1 second. So I do that. Okay, the bracket was just a bit messed up there. That gives us 32.311. 32.311 goes on like that. And if I put this as negative, it should be negative, because we got this answer. Okay, that's where it's going to be the positive value. That's where it's going to be the negative value. It's going to be just negative 32.311. We can confirm that in case you're not sure. You can just put, instead of, it's going to be the negative square root of 2/5, which gives you, as we said, the same exact answer, but negative. So now our final answer is theta equals, you could say, negative 32.3 degrees. Does it say to 1 decimal place? It doesn't say, but we should know that we give answers to 1 decimal place in degrees, unless otherwise stated. Okay, so minus 32.3, 0, and 32.3, rounded to 1 decimal place, and there we have our answer, or our answers for this question, part B. So we use the answer of part A to solve it. All right, so that completes question number 4 from this February-March 2024 Pure Mathematics P1 paper from Cambridge. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from this topic of trig identities and equations from P1 of Cambridge can be found in the playlist over here. Now, I'm going to also include a playlist here from P2 of EdXL, which corresponds to the same kind of level as P1 of Cambridge for this topic. Okay, this topic of trigonometry, trig identities and equations. I'll put a playlist there because there's lots and lots of questions I got from that, and they're very similar, so you'll be able to see lots of other examples. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.